Warm greetings to the respected exhibitors and speakers present here. Before I would like to begin, I would like to thank Roof India for this enormous event and also to invite me as a speaker to this event. When they invited me to this event, I thought on what I'll take as a presentation because I'm into the pre-engineered building industry and everyone over here were taking presentations on the products and allied products related to it. So I thought maybe I'll talk about the structure which is beneath the roofing. So to introduce myself, I'm Mukunth Krishna. I'm a second generation entrepreneur. I'm the director of Armour Steel Buildings, which was started in the year 1994, almost 32 plus years now. The topic of my presentation will be on roofing for single and doubly curved roofs. Yeah, I'll just present one of the four single and doubly curved projects that we have done in our company. Yeah. First, to begin with, the Roof India exhibition is a very big exhibition of to portray the roofing products and allied products. Has anyone thought why we need roofing and what is roofing? We have an excellent setup over here of stalls and a seminar all over here. We could just conduct this seminar and exhibition without the roof, right? But we cannot. We were taught that every human needs basic needs, which is food, clothes, and shelter. Without shelter, the human ecosystem cannot live. So, roofing is providing a necessary shelter which protects us from rainfall, heat, and any hazards and providing us comfort. The single and doubly curved roofings are roofing systems which elevate the structure aesthetically, providing functional and optimum usage of the infrastructure. The first project I would like to present is the CODISSIA bird structure located in Coimbatore. The architecture firm for this project was Gayatri and Namit Architects from Bangalore. The structural consultant of this project was Mitran Structures. The fabrication was done by us. The year of completion was 2010. This structure has an enormous span of 52 meters in length. If you can imagine, 52 meters is the same length as of the hall which we are sitting here from end to end. It has cantilever projections and roofing on both the sides. This structure is the entrance structure for CODISSIA Trade Fair Complex located in Coimbatore. CODISSIA Trade Fair Complex in Coimbatore, if you don't know, is the same convention and exhibition center which we are in right now, that is Bangalore International Exhibition Center. If you had entered Hall 3 before coming to this exhibition, there would have been a tensile structure where we have done the registration. So for the exhibitions which are happening in CODISSIA Trade Fair Complex, this is the entrance arch where you have to do the registration. Since it is a single curve structure, the 52-meter length structure is only supported by two base plates. There are no intermediate columns in it. Can you imagine? 52 meters in length, supported only by two base plates. Immense accuracy is needed to achieve this architecture. Back in 2010, we did not have the tools like Tekla detailing and AutoCAD were not very popular. We just have to do what the architects give us from the drawing. The fabrication difficulties we followed in this project were we used circular sections of 1.1 meter and 0.5 meter. It was manually bended and welded to achieve this curvature, provided with the X bracing in between of the structure. Very meticulous fabrication and quality standards had to be followed to bring the curvature of the structure. Other photos. You can see the entire structure is only held up on the curved structure of the building. Those are two big pipes over there, if you can see. Above the curved structure, to provide the roofing, tubular sections are provided on all four sides, which is to provide the roofing for the area, which is supported on the single structure altogether. In spite of the complicacies of this structure, to bring out the vision of the architect to attain this curve shape, we were able to achieve with attention to detail and dedication. It had to be completed before the World Tamil Conference 2010, called as Semmoli Manadu, which was inaugurated by our late Honorable Chief Minister, Mr. Karunanidhi. This is one of the landmark structures in Coimbatore. This welcomes over 30 lakh plus visitors a year, with over 50 plus exhibitions held inside the trade fair complex. The next project that we will be looking upon is inside the same premises of CODISSIA Trade Fair Complex, Hall D. The architecture firm is the same, Gayatri and Namit Architects from Bangalore. Structural consultant of this project is also the same, Mitran Structures. Fabrication was done by us. Year of completion was in 2008. This structure is a 50-meter long free span curved structures with 1.5-meter depth girders. You can see the structure above, the structure which we are present here right now. This was done in PEB, pre-engineered buildings, connected to every joint. But this single beam is a single beam of the length of 50 meters. 1.5-meter deep corrugated box girders has been fabricated and erected to achieve this curved profile. You can see the difference of the rafters which we are in the building right now compared to this. This is a single piece. This has connections connected here over the top. In the year 2008, before corrugated beams were popularly or used or manufactured, if I'm not wrong, JSPL has started manufacturing of corrugated beams right now. We had to manually fabricate corrugated beams in the year 2008. 4 mm plate corrugations were made using press bending machine back in 2008, and it was box welded to the flanges in curve shape. Everything was done manually. An extreme effort was required to fabricate the single box girder of corrugated beam. The roof purlins were triangular built-up purlins, not the regular purlins which we use in pre-engineered buildings. So everything has to be fabricated separately and then fabricated and erected. Huge amount of labor and welders are required to fabricate the triangular purlins and to be laid on the roofs. Triangular purlins has circular hollow section in the shape of triangle. All three pieces has to be welded in a certain distance towards the length of the every bay. The corrugated box girders have been lifted by two 50 metric ton capacity crane. The erection was extremely difficult due to the lateral difficulty in arresting the lateral torsional force and the buckling of the structure. While lifting a curved structure like this, the single piece of the structure will be shaking. So immense amount of safety and structural stability of the building need to be followed during the erection, which we were able to achieve it. This is an erection photo. And from the building, we can see a lean-to shed with pertubed lens with slanting web columns have also been maintained. Those were also corrugated web columns, manually corrugated using press bending machine of 4 plate. Structural stability of the building has to be kept in mind for lean-to sheds like this, and fabrication and erection of the slender section had been followed. The structural stability was followed by providing a brace corrugated beam with the bracing which supports and holds the lean-to structure of the building and the curved structure in between. In the previous slide, you can see the entire curved box girder is being held up by the down brace. The right corner you can see a corrugated beam with the bracing is holding the curved structure, which is again extended outside for the lean-to shed. The same right side brace of corrugated I-beam is extended outside as the web column. Crimped metallic sheets were laid on the triangular purlins forming a curved shape. This is the backside of the building. You can also see the corrugated columns being on a curved shape, which was very difficult during that time. Faster and timely completion was required because of the opening and inauguration and an expo being on the deadline of the completion of this building. As you can see, the exhibition stalls like which we are in right now had already been installed before the completion of the building. This is during the expo. Once the roof is done, they conducted the expo and the cladding was completed partially. Similarly, we did CODISSIA E Hall, an adjacent hall next to CODISSIA D E Hall. It is a 50-meter free span conventional truss building with curved corrugated box columns as curved structure. The same metallic sheets were laid. This is Hall D and E. It was inaugurated in the year 2008. Overall square foot area of 1,35,000 square feet. This state-of-the-art convention center for CODISSIA Trade Fair Complex. You won't believe, both of this building in the year 2008, manually corrugated columns and box girders and triangular built-up purlins. We completed both of these buildings in 90 days in 2008, which was recorded in Limca Book of Records. A steel structure took 90 days. The overall completion of the building took 155 days. We were awarded Limca Book of Records for fastest construction. The certificate is on the right side. You can see the amount of labor effort put into this. Almost 1,500 workers work for 155 days. It's a huge landmark for Coimbatore to conduct exhibitions. Next is an interesting project I would like to present, which is Shiv Nadar School, located in Chennai. The architecture firm for this project was Vastu Shilpa Sangat LLP. Structural consultant is Manjunath and Co consultants from Bangalore. Fabrication was done by us. The year of completion was in 2023. The design concept of this building, the management bought the land in Nadar with an eco-friendly environment of 1,400 trees present in it. So they didn't want to disturb any of the environment. And the roof structure is in the shape of a banana leaf, designed to foster a porous and breathable learning environment. You can see on the left corner of the photo, the trees were not disturbed, cut or taken away. The roof sheet travels along the tree and it is also a part of the school building, as you can see here. The 3D Revit drawing of the building. It's a very complex structure, very difficult to be fabricated and erected. And Huge accuracy is needed to achieve this shape, or else you won't get the finishing of the roof. The structure was exactly erected, fabricated and erected as given by the architect. It is very difficult to exactly recreate the 3D drawing into reality, but we were able to achieve it. The truss drawing of the building. We use circular hollow sections of 114 mm diameter, 76 mm diameter, and 42 mm diameter were used as top and bottom chord of this curved truss. In this project also, pipes were bent using hydraulic pipe bending machine to achieve the curve and radius required. The bending acts upon both on X and as well as Y axis. The pipe joints were not directly welded on the surface. The pipe joints were laser cut to provide a notch, and the pipe joint was fixed into it and then welded. Before proceeding for fabrication, we did a miniature because the architect gave us a 3D. So he wants to make sure we are able to achieve the curve and radius in the exact shape. So a miniature was created and got approved by the consultant as well as the architect that they will be able to do this. This is the assembly of the parasol truss. So each and every truss was fabricated and assembled like this, transported to the site and erected as a single piece to attain the shape of the building. Erection difficulties. Since I already explained, there were 1,400 trees present in the environment. So without disturbing the environment, we had to erect using a 100 metric ton crane to achieve the radius of 10 to 20 meters in distance, and the structure was lifted and erected. You can think about the amount of difficulty we had to face. It is not easy to erect from a long distance of radius and assemble the structure in the same position. If a single position misses, we won't be able to take the curvature of the shape of the building when the structure is erected. The other photos of structure fabricated and erected as per the architectural 3D drawing which we had received. The structural stability of the structure was achieved by having 5 node points welded to the bottom chord. You can see a lot of XX types pipes. So those are 5 node points welded towards the bottom bend curve pipe. A silver bend pipe, you can see it in the photo, a long pipe of 165 mm circular hollow section pipe. So the entire parasol truss is held up on the bottom down bend pipe, and together both of this is posted on a 300 mm circular hollow section 2 station columns. Only 2 station columns on both the sides is handling the entire structure. And also another beauty to this building is the roof structure is no way connected to the classrooms present in the school. You can see that the civil buildings are completely away from the roof structure. The roof structure only acts as a shelter in this school. It is not connected to any other infrastructure in the building. Inner view. The environment of the building was not at all disturbed during the erection. You can see the greenery inside the building. Outer view of the building. This school is a testament and an example of an eco-friendly green building located in Adayar, part of Chennai, with a lush greenery of 14-acre campus It is a combination of eco-friendly environment envisioned through the management, architects, engineers, and eco-friendly education. You can see from the photo, if you see the top of the photo, the whole of Chennai is developed as continuous civil buildings. But this campus stands as an example which is separated from the infrastructure above, full greenery in this. It is a great example of envisioning a curved roof structure, a complex curved roof structure in the shape of banana leaves among 1,400 trees. Next is one of the landmark projects that we have done is the PSD Convention Center and Auditorium located in Coimbatore. The architecture firm of this project was SD Sharma and Associates from Chandigarh. The structural consultant of this project is Nitran Structures. Fabrication was done by us, which is Armour Steel Buildings. We completed this project in the year 2021. PSD Institute of Technology's new expansion college was a huge college. So they had to plan the auditorium in front of the campus where we can enter. So if at all they had planned an auditorium in a very normal way, there would have been an obstruction. So the management had a clear vision of not having any obstruction when they enter and then see an auditorium. So they had to go with the 360-degree view. So this is a 54-meter concrete drum with intersecting arches forming a contemporary dome, providing 360-degree viewing experience. This is a 1,500-seater venue in Coimbatore, a monolithic design, and roofing was done in double curved sandwich roofing system with international standard audio and visual systems for major performances, conferences, and for the college's use. This is a 3D view that was put up first by the architect. Vision that was developed by him. Design sketch of the building. Huge complex and intricacies of the building. The building consists of a basement, ground floor, and first floor. This is the auditorium section drawing. You can see the levels and the stage and how they have directed the eye view of the audience seated there in the auditorium. Design drawing. The detailing was done in Tekla modeling and the general arrangement drawing was done in AutoCAD. To attain the curved structure, the curved plates were cut in CNC plasma cutting and an automatic H-beam line welded by submerged arc welding. The width of the machine is 2.5 meters. So if the curve is below 2.5 meters, we will be able to do automatic welding. Box girders were used as end columns with intermittent stiffness and box welded. These are the fabrication photos. The first floor gallery of the auditorium is 12 meters in width and it is a free span of 36 meters in length, holding 300-seater capacity. The box girders are of 2.3 meter in height and 1.8 meter wide of 32 mm plate was required to hold 300 seats in the first floor gallery. Cross beams were provided with composite deck slab with shear connectors were followed as the flooring. If at all anyone wants to know what is shear connector, there's a stall right opposite to us. It is a new technology in composite deck slab flooring. The gallery girders was erected as a single piece with high crane capacity of 100 metric ton and 60 metric ton with 1.5 meter, 1.2 meter length. of each box girders. Each box girder were 29 metric ton of total weight. The whole structure is of 90 meters in length and 68 meters wide. The top height of the structure is 17.1 meter and the clear height is 15.1 meter from inside. I section rafters with box column towards the end with 200 diameter were used as circular hollow section purlins were used. You can see the curve shaped rafters erected as a single piece with utmost difficulty, which is on CODISSIA D E Hall. Erection photos. Curve shaped box columns in photo. The end columns are box columns with intermittent stiffness. You can see that each of the curved rafters and end columns has to be positioned exactly on the pedestals, where you can see the civil pedestals, or else you won't get the position and the shape. The survey accuracy required in this project was very intricately followed by the management consultant as well as the architect to attain the shape of the building. Another erection photo. So once the skeleton structure is ready, so like our human body, the bone which we have is the skeleton, skin is the which is covering us. If the bone is not in correct shape, we won't get the outer look which we have right now. So the geometry of the building is very important to showcase the beauty of the structure. So the purlins were 200 millimeter dia circle hollow section purlins. Total number of 875 purlins were used, bended using hydraulic pipe bending machine, and each and every purlin is on different radius and curvature. 875 purlins of different radius and curvature was fabricated and erected to form the dome shape. The double glazing support were also followed by the same purlins. This is the purlin connection detail. Both the circular hollow section pipes to join above from the plate. This is a gusset plate. So we cannot leave the plate just like that. For the roof sheet to be laid, the shape has to be followed in the same slope as the curved pipe. So a bit of a curved pipe was cut and welded over the top of the gusset plate on 875 purlins of the whole structure to form a same slope of the circular hollow section purlins. You can look at the extreme difficulty of fabrication and erection that had to be followed for the structure. This is the final skeleton video. Which if you can remember, you would have seen the 3D sketch at the first slide with the green lines. The same thing was achieved here. 875 purlins acting as a skeleton in different radius, curves and different positions. Next, the roofing system is an important system of this building. The roofing system consisted of calzip liner roof system. Zinc allium liner sheet was laid on the purlins of the building, and above that 100 glass wool thermal insulation was required to maintain temperature difference and high acoustic standard for the auditorium, and hat purlins were used to position the insulation, and an aluminium E-clip with a vapor control layer was required to restrict any air penetration or vapor penetration to the building, and on top of it, aluminium standing seam roof sheet was used to attain the curvature. Only aluminium can handle the type of flexibility and curvature of intense curved buildings like this. doubly curved buildings. This is aluminum E-clip with vapor control layer topped with the standing seam roof system to resist any air or vapor penetration present. Fully laid liner sheet over the top. The hat purlins were laid for the thermal insulation and aluminum roof sheet. Calzip aluminum sheet was produced at site and erected. You can see the curved shape of sheets produced. This is the finally fully laid structure of Calzip liner system with zinc alum liner sheet, 100 glass wool thermal insulation, and over the top aluminum Calzip standing seam roof system, which forming as a sandwich insulated panel, which elevates the 3D view and the vision created by the architect at first, and also acting as a high thermal insulation and giving great acoustic benefits for the auditorium. I think there is no Calzip stall in the exhibition, where we cannot see. There are only puff panels. If we require thermal insulation and acoustic benefits, we need to use puff panel. But puff panel cannot be used on structures like this. So hence, it was proceeded with the Calzip liner system. Aluminium has better flexibility tension ratio compared to steel. That is why the shape was achieved by aluminum roofing system. So I would like to play a small video that showcases the vision of the management architect, the consultant, and the workers to deliver this magnanimous structure. You can see the box columns that was erected, which is inside the building.
This is a vision of management to give something to the city, which is a landmark, both in terms of architecture, both in terms of functionality. Now, what does an IT world, a corporate world, or a medical world needs? A space to display, a space to gather, interact, and to have an office. But this is a requirement placed as a 1500 capacity. Now just imagine a building of this nature and this size could be really an obstruction, but the magic just was very clear. Visibility from the Avinashi Road, but no obstruction on the campus. It was something which went 100 options, 100 sketches, and models working and reworking. So I think the whole area which has come out is something which we all are actually wrong.
Initially, we came with a very random design, and we were doing different kind of forms, twisted, turned, semicircular. And that's when the managing director came up with his inputs and was very clear with us. He wanted a monolithic building and also wanted a very simple geometry. He felt that a simple geometry always stood in time.
Started a year back, wrote so much interest among the public. Some saw it is a catalyst for curiosity, some thought it is an art form, and many tries to understand the logic and functionality of the construction. Nevertheless, it is an elliptical dome of inner dimensions 26 meters and 68 meters, with the outer dimensions 68 meters and 90 meters, rising to the height of 2 meters. The structure has got a basement, the middle floor, gallery, and pool. The gallery is 12 meters by 36 meters. The 36-meter direction, the supports have been laid. The construction was done with simple elements. The roof sheet is a special form. The roof sheet consists of a base. Over that, a half section has been laid. Over that, vapor barrier and thermal insulation. The top is covered with aluminum sheet profiled to the form.
The shell-shaped envelope was housing all the services, all the functions inside the space. Therefore, it was very important for us to position all the MEPs inside the first corridor, and the outer corridor becomes the entry point as we see here. And that's where we decided to go with this kind of a glass facade where the natural light enters. The double way curvature that you can see in this glass that's going horizontally as well as vertically was very difficult for us to achieve. Once we started designing, we went with the concept of geodesic domes. That is, these simple tessellated triangles kept in a direction of curvature, which were both tiltable both in both directions. My design in this case was the amount of volume that was available inside. The scale almost 10 times that of a human. Therefore, we wanted to keep this as the main point. Talking about the interior was equally important for us as important as the facade. The curiosity was already created in the facade, and we had to continue that inside, keeping the expectation. Scale, the number of light fixtures are really high. What was more important for us is to create a scene by combining all of them together. There where the lighting control system had to come in place. The lighting control system helped us in integrating all the lights together, wherein we could dim and brighten the entire space, therefore creating a light and shadow effect and also controlling the day and night effect inside the auditorium. The main advantage of this lighting control system for the client was the ease of operation. The entire lighting system came under one app for the easy touch of on and off. Common areas, we wanted to go with the theme. So we were thinking of that something that will echo about PSG and the history behind it. After the thought process, we came up with none other than their diamond, that is their logo, the PSG logo, which is almost a century old. So to enhance it and to further give emphasis on that, we decided to feature that as a main design element in all the areas around. The water body around creates a beauty effect, and the sitting space has been created around the water body for one to sit there and look at the building and the landscape around. The convention center, the water body, covered an open pathway, and the landscape around blends into one, forming an organic experience.
In line with the vision of the management, we decided to have the facility complete in all aspects in terms of infrastructure, equipment, and services. The convention center houses an auditorium with a seating capacity of 1,500, installed with sophisticated audio, video, and lighting systems. It matches international standards in terms of acoustics, comfort, and ambience. The gallery spread across 14,000 square feet has been set up as exhibit space. 3 meeting halls of various capacities are also available. Conduct the breakout sessions and panel discussions apart from green rooms and boardrooms. Everything is housed within the unique dome-shaped structure. The convention center is strategically located in the highway at the entry point of Point 2, in close proximity to airport and many upscale international domains.
Contributing significantly towards education, healthcare, and entrepreneurship development in this part of the country. As yet another contribution to the city of Coimbatore, we are very happy to dedicate the state-of-the-art convention center. We strongly believe this facility will improve the city and thereby bring professional conferences, events related to fine arts and culture. Welcome to the BSC Convention Center.
It was a very happy and proud moment for us that the PSD Convention Center was awarded the best convention center by Economic Times in the year 2025. And we got a great testimonial from the client for this enormous project. This facility consists of 1 lakh square foot area. It is an important landmark which can be seen while you enter Coimbatore from Salem-Kochi highway. It also embraces the 100-year-old legacy of PSD Sons and Charities educational legacy, which acts as an important landmark in Coimbatore, elevating Coimbatore's infrastructure. All this wouldn't have been possible without teamwork. So I would like to end my presentation with a quote from Andrew Carnegie, an American philanthropist and founder of Carnegie Mellon University, which is one of the top 10 universities in the United States. Teamwork is the ability to work together towards a common vision, the ability to direct individuals towards organizational objectives. It is the fuel that allows common people to attain uncommon results. All the 4 project case studies that I showcased today wouldn't have been possible without the teamwork to attain something different, which was only possible by the architect's vision, structural consultants' intricate detailing, fabrication, erection, and the labors, and the support of the client. With that, I would like to end my presentation. Thank you.